more about Tufo. So someone in the chat mentioned they wanted the source code. I did paste it in there. I'm pasting it again for now. Make sure that I'm actually streaming. Okay, I am streaming. So what I'm going to do is I'm going to paste it in again. The session still shows offline. A little tricky here. So we are already into the session though. So I'm going to paste it again. So now I pasted it numerous times. Also on Twitter, I keep pasting the link to everything. So and I'm seeing that we are live. Okay, so what are we doing next? So we got our just to recap real quick, we got our player working. One thing that I wanted to fix actually, I was thinking about. I said, well, we want to apply thrust one time and so on. But the thing is, thrust force. So if you let's say your game loop is really slow, and you press a key the same amount of time, now actually the player would accelerate less, right? Because you're getting less times. Basically the game loop applying your key press. So actually, what we need to take into account, we do need to take into account WT, like the time that passed since the last update, so that no matter how many times you call the update method, the DT will kind of normalize how many times or like how strong of an acceleration you're actually applying. So what we need to do here, when we do the player update, and the move is fine, but basically here when we do the game up, key up, we need to include the delta t. So we include that here, and we add that to here, double dt. And so now what we'll do actually, we will multiply each of them with dt. Okay. And so now we have to make sure, obviously, that our constant still makes sense. So we are still spinning, and now we are actually very fast. So dt actually made it, which is actually surprising because I would have thought that it's smaller than 0. But we could clearly see that we are flying off really fast. So we'll just fix these a little bit. So what I'm going to do is, I'm going to just make the thrust force 1/10 of that. And I'm going to restart. Okay, now we got about the same thing, right? Okay. So that fix. So we can actually, that was a quick fix. So when I'm actually going to add that as a commit, and then we're going to tag that. So, and we're going to say this was actually like this at the start, because this is not still part of the previous episode in a way, just fixing something we didn't do correctly. So we'll do that. I'm going to tag it, and then we push and we push tags. Okay, so now we basically got this game a little more realistic. Actually, you can see here that we have an autofix going on. If we're flying off the tile map, the world position will basically be calculated to be somewhere outside of the canvas, but then when we convert it back to a tile position, we automatically get pushed into the 0, 0 tile again, which is kind of a nice side effect. So here we have the same situation, right? We can't leave our world, which is cool. Okay, so now we can actually get to the next thing, which is going to be a sprite sheet. So I'm going to already create the file here. So what we want to create a sprite sheet. So what's a sprite sheet? So we're going to look at one right now. I'm going to take one from something that I already have. And so we're going to take one, and the sprite sheet is basically something. So can I paste here? Okay. All right. So we're going to call this thrust. So this is the sprite. So we can see here that we got, and again, I downloaded those from some site that gives those, provides those. Some people create those and then they provide them for free, different licenses, or some of them you have to pay. But this one was a Creative Commons 00 license, or Creative Commons 0, whatever it's called. So we can freely use it. So you can kind of see here, this is like a sprite sheet that is all in one row. There are different sprite sheets. So I'm just going to show another one here. So this is a sprite sheet that has multiple rows and multiple columns, which we're going to use that later. For now, we're going to keep it simple. So what we basically want to do is we want to basically grab all these sprites. So these are all images, right? And so we kind of want to grab them out of here. And you can see that each of them have the same width, roughly. Not roughly, but exactly. Otherwise, it wouldn't work. So we know that each of those sections will become one of the sprites. And then when we then play those, we render those sprites really quickly after each other, it gives us the illusion of an animation, right? Something is actually animating. It's kind of like a flip book, right? So what we're going to do, though, because this is something that Flame got pretty right, we're going to look somewhat at this thing. At least I'm going to have this over here on the left, and I'm going to get some ideas from there, right? But again, I don't want to just copy paste it, because I actually want us to understand how these things work. So so first of all, we need a list of sprites. Right, so we need a list of sprites. And if you looked closely enough, Flame has it as a list of sprites. And I don't think that's really necessary. Unless we wanted to get wrong column. But the thing is, all our I guess there are sprite sheets that could have unrelated sprites, where you would maybe want to index into exactly row and column. But we can even do that if we flat, if you have a flat list. The same we did with the time map. We can still represent it as a flat list. And if we ever need to access by row and column, if you know how many columns there are, we can map that back to our flat list. So I think we're totally fine just keeping it as a flat list. So these are our sprites. Now, when we create the sprite sheet, we need to actually get this from an image, right? And so basically, when we have the sprite sheet constructor, we need to give it an image name. So this is going to be a string, and it's actually going to be an image path, right? So let's just leave it there for now. So what do we do when we have that image? So what we'll first obviously do, we will load, we create a sprite from the image. But we create a sprite and we'll tell it where in the image to pull things from. And that's where kind of the dest and the source came from. Remember, like when we did the sprite a few episodes back and we ran into trouble, like we only were rendering part of our spaceship. That's because it was pulling a part of it that was basically applying a rect to it. So, which means that we have to probably look also at the sprite class of Flame, because they did it slightly different. So maybe we first need to fix our sprites. So you can see here, but basically, I'm just going to show this. So basically what they're doing here is they're saying, okay, get me a sprite of the image name. And then start, like they're finding basically a rect here. This is the left upper corner. And then basically this is width and the height. And then they basically, what they can do is grab just a part of the image. So if you have this whole image here, and I say, grab me this rect, then that becomes a sprite, right? So we need to basically make our sprites allow us to do that. So right now we only have width and height, right? So what we also need to be able to do is we need to say double, give me the x, and it's basically 0 by default, and give me the y as well. It's also 0 by default. And so what we then do, we load the image, right? And then let's see. So let's see how we actually use this. So here we gave it the width and the height. This is actually a little bit confusing, because this is like the width and the height that we want to render it at. So we might actually have to do a bunch of changes here. So basically, there are, yes, there are two different things. There's like, yeah, it's interesting. So basically, I'm actually going to show this. I'm actually looking through this and trying to understand this. So maybe let's look at this a little closer, because I think that maybe our sprite right now is not really accommodating to do a sprite sheet very well. So what's basically happening is we're doing x and width and height. Okay. So then basically, we are then assigning our width and height, which is basically the so we're overriding basically the width and the height if it's not set, right? So we were setting it, and then we're basically creating the source rect to be x and y width and height. So that means like what part of the image are we actually showing, right? So what part of the image? So we'll just say in this case of an image, we might say we want to have this rect, or we want to have this rect. Our sprite does not accommodate for that yet. So that's the source. So the question is, when we actually render it, how it knows how to render it smaller, right? And this is kind of where this comes in. So when we say render, we actually give it width and height, and that only affects the dist, right? So that's the dist rect. The source is always constant. So the source is basically our image, and the dist is basically how we want to render it, how big, and where, right? So keeping that in mind, let's see what we have in our code. So it looks like I got myself lost here. So we got x and y width and height. So now what we actually need to do, instead of what we were doing before, we actually need to create a source rect, and we are not doing that yet. So we're creating a source, and that's a rect from left, top, and then width and height. And so we give it our x, our y, our width, and our height, right? So the thing is though that width and height could be 0, and so we have the size from image here, and that's basically what that is. So we can say size from image, and this is where it gets confusing, because this is where we're setting our field width and height, which probably don't want that anymore. But we instead want that source thing. So, but this is not. So we'll probably move that over here. So with and then basically we'll just basically do it the way they did over here, which makes actually more sense in this case. Okay, and the loader tool we put at the bottom. So now basically we don't need this anymore. Size from edge disappears. Right, we're gonna see what we'll do about this down here. But now basically we have a rect source. Okay. So basically we're saying it's from X, Y, width and height. Okay, fine. So what we do, we just apply these changes, and then we make sure that everything still works as before. And we can see that in the here they actually duplicated this code. So for now we do the same thing. We may later decide to factor this out, but we need to create the source. So basically, actually, what we can do, we actually can pull this out in a. Yeah, we can pull it out in a method. Prepare source. So now we can do the same thing here. Oh, well, that's not what I meant to do. Prepare source goes to the bottom here, and we want to put that here, and we also want to put that here. All right, so now at least we have that. Let's see. So we have X and Y. Now they have the same. Okay, so we need the same defaults here. All right, and then we do prepare source. All right, and so basically, what we also do, we assign the image. It's fine. Let's just call it init, and then it could be anything. Otherwise, we wouldn't ever think that the image thing gets assigned there. So we just want to call it init, and then it's loaded true. And then actually the loaded true could go into init as well, because once we initialized, we are good, right? So now we basically creating our source. Okay, and now here we want when we render, we want the width and the height. But the thing is that we need to actually supply that now, right? The width and the height, we no longer. I mean, you could have a render width and render height, right? Because that's what basically this is. Basically here, what it requires on in the Flame engine, it requires us to pass it in. We pass in the size that we want to render at, which is probably not so bad either. Yeah, maybe we'll just. Yeah, if you ever want to, like use the same sprite, but we want to, for instance, grow the image. Like maybe you want to. Yeah, I don't know. Maybe, but let's just do it this way. It's fine. Okay, and then and actually those are required though, because without them it doesn't make any sense, right? Because now we could probably default to something, but I don't know what we would default to. So okay, so here we go. So we can't. So just remove the toString here. It doesn't make any sense anymore. If Sprite isn't used, okay, that's fine. We can live with that. So SpriteSheet, which we'll do in a second, once we actually fix what we need to fix. So here we have height and width is required, and this actually now happens when we create this player sprite. So here the width that we gave in the tile size, we'll actually provide that instead to the when we render it. Okay. And so now we actually need to make the tile size a field. And it's also required. Okay. So now what's happening? So we're creating this. We're creating the sprite just from the image path. And here we're basically giving no width and no height and no X and Y. So that means we want the entire image. Because now if you go to init, and it has no width and height, we'll just assume we want the entire image height, image width, right? So, and actually what I'm going to do, I don't like the order of things here. I want to, where's a way to change the signature? Please let me change the signature. Code. There must be a way to change the signature. Okay, I guess there isn't. So we'll just do it by force. We want obviously X and Y before and then the with height. So now obviously everywhere we call it, we need to change it. It's be X, Y with height. With height. And then there must be another init call somewhere. Okay. So now that makes a lot more sense. So we're passing X, Y. In this case, it's X is 0 and the width will not be defined, the height won't either. And so if they're not defined, I will just take it from the image. And then we get this whole image, so we get our source. Then when we render, we define the source is, we already have the source. So, and then the destination will be determined from whatever width we give here and height. And from wherever we want to render it, that's our destination. And so basically the image will be rendered into the destination. Hopefully that will just work. And so now if we do a refresh, we're still rendering correctly. So we did something right. Okay. So basically what we're going to do, we're going to check that in. So we basically set Sprite factoring to support SpriteSheets. Okay, so now, because now what we can do in the SpriteSheet, we can now define different sections of the image. So looking at the SpriteSheet, so the SpriteSheet, we they in Flame they define as texture width and texture height and columns and rows. So a texture, I think they consider like a sprite width and sprite height, right? So each sprite has a certain width and height. So we just name it that, and then have a number of row and columns. So and all these are actually required. So they need to be passed to it. And the thing is, what I don't understand is why they need to be fields. Most likely so we can access them. So actually it's not a bad idea. We can just make it into fields that then we can also print on toString or whatever. So basically what we have an int. So it doesn't make sense, I guess, to have doubles for texture width and texture height. So we have the sprite width. So you should probably never have a sprite that has a fraction as a width or a height. So we have the sprite width and sprite height. Okay, so that's basically, if you look at our source image here, right? This is the width right now, and this is the height, and then each of them have that same width and height, right? And then we need to know how many rows and how many columns, right? And so in this case, right, we have one row and we have a bunch of columns. The thing is, though, that if we know the width of the whole image, right, we could actually calculate that, but that's not overcomplicate things. So we actually here have the width right here, right? So we already know that the height of our sprite is 442 in this case, and then the sprite width is like 7,700 divided by however many there are. Okay. So what we'll do, we need actually all of those, or we can maybe default some. So what we'll say is we need the image path, and we need the sprite width, definitely, right? So so this is required, and actually it makes no sense to have this as a property. This is like something that is the first thing that you want to pass in anyway. So this is the image path, and then we name the other things. So we say at required this dot sprite width, sprite height, and then required this dot rows, and then columns as well. All right, so okay, so now basically we can go ahead. Once we have that, we can actually generate our sprites. So what we'll do is, for now, we'll just take the rows and the columns, and for now we only solve for if the column is 1, right? Actually, let's already maybe. So we have rows and columns. So we are in a certain row 0, and then rows, and row plus plus. Okay, so we start in the first row, then we do the same thing for call. Let's name it calls. I don't like them to have different different lengths. So that would be calls and call plus plus. Okay, and so now for each one of those we need to create a sprite. So let's just calculate the x and the y for this stuff. So the x is basically the row, the column times the sprite width, right? And the y is the row times the sprite height. So that's where we start, right? So let's look at the other thing here. So basically, if we hold this next to it, make this smaller. Okay. So basically, if we take this sprite, so let's just say we're trying to render this one. So in this case, we would be in the second column, right? So x would be whatever the height is. So it would be here. The y would be that, right? Whatever the height is. And then the x would be whatever the width is times the column, right? So it's row times sprite height and column times sprite width. And so then, next thing we need to do is we need to then assign, move my microphone again, sorry. We need to then assign but it needs to be double, right? Because we want to double for all this, but we can later do that. And so we need to then create a sprite that has that. So now the other thing we need to, the width and the height is basically exactly the texture width and the sprite width and the text height. So we're going to say the width is the sprite width dot, and we're going to do double because our sprite takes doubles, and the height is the sprite height. And then let's go ahead and convert this to double as well. Do double. And do the same thing here. And now we can create our sprite. So our sprite now is sprite, right? And it's basically, we give it you can see that we give it the image name, or the image path. And then we give it the what we just calculated, right? So sprite path or image path. And then we give it x. What's x is x, y is y, width is w, and height is h. So now we have that sprite. And then we basically could just add it to our list of sprites. But we need to be careful here. We're going first row, then column, right? So again, if we have multiple, like, so we're going first row, we do all the columns, right? Then we go to the next row, we do all the columns, and we add it just like in our list, we just add it like this, like really long. So we just gotta be careful that we have that order right, to where if we want to index by row and column ever, we can do that. So now basically in sprites, we just add this sprite. We could also have pre-allocated this list, but that's something we will do if we ever run into performance issues, which I doubt, because this happens one time we create the sprite sheet, right? And we probably will create the sprite sheet not every time we use it, but we create it once and then we'll reuse it or something like that. So now we got a sprite sheet, okay? So now let's implement a the get sprite at row and column or whatever, because we might actually need that. Well, actually, let's not do that. So what we actually want to do is we want to get a sprite at a certain index. Get at index, something like that, or right. So then we have the index, and then we say, well, first of all, we want to assert that we're not out of bounds. Assert index is smaller than our sprites dot length. Otherwise, we say index is larger than sprites dot length. Okay. And otherwise, we return sprites of index. Okay, so we now can circle through our sprites. We could argue that the sprite sheet may allow us to basically just get the next. But until we need that, and until we are sure that the sprite sheet should be responsible for that, we won't do that. So then here in our flame, we have a create animation, which, in my opinion, doesn't really belong here. Also, the animation is another class, and so we'll actually do a sprite animation first, and then we'll look at if we need other animations as well. So we'll look through the animation here, what that does, and the animation has a sprite list and all this stuff. So we'll do a sprite sheet animation out of this. But basically, what all the animation has to do here is step through the index, right? Step through all the sprites, and then if it gets to the end, it needs to either start at the beginning if we're looping, or just stop, right? But for now, we kind of want to see if this actually works. So how can we do that? Well, what we could do, we could add a thrust to the player. So this is obviously the thrust, right? Like this is when we accelerate, we want to show this as an animation there. But what we'll do first, we just pick one out of here, and we'll just show it on the player. So when you render the player, right, we want to kind of show thrust. And what we'll do for now is in the player model, we're going to say we have a Boolean in here, applied thrust, right? And the thing is, we'll set this whenever we see the key being pressed, and then we'll unset it immediately, right? Because we only want to start this animation once, right? So basically, once we apply thrust, we'll tell it to start the animation, and then we forget about it. Like, this is not something that we want to actually keep track of necessarily. Like, those are animations, and already thinking ahead a little bit of when this will be multiplayer, and we will send things to the server. We don't want to update the server about every step of the animation of the thrust. No, we just want to tell the server maybe that the player applied thrust. So if another player, like, we're playing against someone, and the player comes flying by and applies thrust, we actually see that. But basically what we'll do, we just like say, oh, the player applied thrust, so let's start his animation as well, like of our opponent, right? We don't want to necessarily send every frame of the thrust animation across the server. So for now, what we'll do when we create our level, where are we building the model? In the models, right? Yeah. When we build this, we'll actually set the applied thrust to true for now, and we'll never set it to false. That means like it will always show the thrust. So now in the player here, when we render it, we say we render the player sprite, and then we say if the player dot applied thrust, then we'll render the thrust, right? And so now we have to think about it a little bit. So how do we actually render? So the thing is, this is the interesting part. We already rotated the canvas at this point, right? So let me. We might not be able to do this now because we have a bug in here. So let's try this again. Let's reload this. So here we have the player, right? So if the player is pointing this way already, so this is like the natural, this is angle 0, right? So the thrust will have to be here. So we draw it like this. So basically look at, okay, here's the center of the player, the thrust would have to be here. And the thing is, we have to rotate it 90 degrees because as you see that the thrust is kind of rendered like this, we want it actually to be sideways, right? So now you're thinking, okay, but what if the player is rotated like this? Well, the thing is, we already applied the rotation. So we can treat this as if the player is actually like this, because the canvas already translates all these drawing actions for us because it is rotated like that. And all we actually do is when we actually do render the thrust, so we find the position where the thrust would have to be, and then we actually rotate again to make the thrust actually appear rotated like this, right? Otherwise we get a thrust that's pointing this way. But we'll go step by step, right? So if the player applied thrust, we render the player thrust. And so the thing is, what we need to do is we need to figure out, so we're already at the center of the player, right? So maybe actually we should not make this a separate method yet. We should just probably keep it here so we can see things better. So we are already at the center. So what we actually need to do now is we need to translate ourselves a little backwards, right? And again, we're always thinking of the player being in this position because that's like angle 0, right? So what we want to do is we want to move a little bit, and so we want to do the tile size. Let's just for now do the tile size divided by 2, right? Because that's roughly where we want to be. And then we want to actually render for now, right? And we will figure out about rotating in a second. First of all, we do need the thrust sprite sheet, right? So we do the thrust sprite, right? And so the thrust sprite, okay. Is the sprite sheet of the thrust path, right? So we need to rename this to be clear, player image path, and then we have another one that's called thrust image path. Okay. And the thing is, now it's getting confusing as hell because we have all these strings, so we don't want to we don't want to confuse we don't want to confuse the thrust sprite with the player sprite. So we have the thrust. So now we need to go in here, need to add that to our assets. And I'm explicit here. There are ways to just import an entire folder, but we don't want to do this yet. So we'll just do it like this, more explicit. So then basically we say final thrust equals, and so we copy and paste it in here. All right, so we have the thrust now, and so we can say the thrust image path, and wherever we instantiate it, we say game props dot assets dot thrust. Okay, except that this is a named property now, thrust. Why? Okay, so we got that. Now we get our thrust image path, and actually, you know what? It doesn't make sense to have just a player like that. So we'll probably name this also player image path. Okay. So now it should be all happy. We didn't really update anything. We need to restart things though. So for now we're gonna close the browser one. We'll close this entirely, and we're actually gonna stop this for now because we need to every time we add an asset we need to restart from fresh. So now we have the thrust sprite, and so now it gets interesting. And so I actually want to encapsulate this somewhere, and maybe not here. So basically what we need to know is we need to know what are the dimensions of our thrust, like how many columns, how many rows, all these things. So maybe that becomes part of the assets, and then we'll. But I'm not sure if the player. I wonder if I maybe just want to make a class that is basically a thrust sprite class, and so we just create a thrust sprite like this, and we give it the thrust image path, right? And then it takes care of everything. So I think I want to do that. So so now we're getting to more folders, right? So we have the engine, we have the game, which is basically all the game objects, which basically right now the player, for instance, is a controller and a renderer at the same time. We have inputs, we have levels. So what we actually want to have is we have, oops, I didn't want to do that. Come back. Up, and now I close my monitor. So window, please come back. This one, please. All right. That is really unfortunate. Okay. That's really kind of fun. So what we'll do is and we'll reopen it. I have no idea how to do this quicker now. Okay, so we are back. So what I wanted to press is Command N and not Command M to minimize. What we want to do, we want to create a package called sprites, and there we create a dart file thrust sprite. Okay, and so that thrust sprite. Basically, what it does, it has a final. It has a final. Well. So what we'll do is we'll define the dimensions here, and I'm basically going to take those from the previous implementation. So you already had rocket thrust, and all these things were defined here. So basically, here I knew that the columns were 50, the width was 7. I already mentioned however many columns we have, we divide those into the entire width, or into the image width, and that's how we get the SpriteSheet width. So what I'm going to do actually is I'm going to yeah, I'm going to basically, so we're actually going to, what we're going to do actually, we're going to include the animation in this thrust sprite at first. And then we are later on going to figure out how we can actually do this without it. So we'll keep this up here. These are privates. And then basically what we can do is we can now create a sprite sheet from those. So we can say our sprite sheet. And the thing is, you can see that we're creating one sprite sheet. And that's totally fine, because all we're doing, we're going to pull out sprites of it. Like, it doesn't have to be multiple instances. So if you can see this here, the sprite sheet is basically just a way, it has a list of sprites, and we can basically just pull them out and we can render them. We can render them multiple times. We don't have to have a sprite sheet each time, or a copy of the sprite each time we want to render it somewhere. This is just a way to basically go through the sprites, right? So if you go back to where we were, so the sprite sheet is basically a sprite sheet, right? And now, but the thing is, I actually want this to be here because I want to pass in, the image path to the constructor. So what we're going to do is we have final sprite sheet, which is a sprite sheet, and we will have a constructor which gets passed in the image. It's kind of weird that we're getting the image path passed in, and everything is kind of hard-coded, which is clearly related to the image path, right? It's kind of weird. So maybe in that case, it makes more sense to have it as a static here. Why is it not heavy? Okay. Dot thrust. Okay. So we have the image path here. Why is it complaining? So it can be const. Okay, fine. So it's a string. No big deal. So we have the image path. And you could argue that maybe this information should be together with the asset. So maybe we'll create an asset class in the future that has the information all encapsulated in one. Yeah, maybe let's do that actually right now. So we have the assets, we have a class asset, right? And it has an image path, and then it has a final. It has the x, it has the y, and it has the. Well, no, hold on. So it has. So we want the. Actually, we want the width and the columns and the height and the rows, right? So we want the overall width, right? And then we want the columns, and we want the rows. That's what that is. And so now we know. So if you have one image like our player, it will have one column and one row, and so we take the entire width and height. And if we have a sprite like the thrust, we have multiple. Okay, so that's good. I just wondered what the order would be. So let's go here. So now we want to actually create a constructor with this. So this would be fine. So the width, basically, the height we need. And the columns and rows, we just always default to 1. Why is it complaining? Okay, so it needs to be name. Oh yeah, because they're optional. So okay. Okay, so we have image. Okay, so now obviously what we do, and the width. Well, I mean, maybe it's useful to have width and height. 536, 534. Okay. So we're gonna have asset. What did I say? Width and height. 536 times 534. Okay, might come in useful later. 536, 534, and then here the width. So here we have the thrust, right? We create the asset, and so now we go back to this one. So the width is 700. 442 is the height. The height, and then we have one row. So row, we have 1, and calls we had, I think it was 50. Let's double check that. So now we have this all nicely encapsulated. But it's basically an image asset, right? There might be other kind of assets. So let's go back to our thrust sprite. So we got that all right. So then basically, image asset, right? It's basically it's a thrust, and so now we can easily create the sprite sheet from that. So I mean, I think you could argue we could almost statically create that, but maybe you want to create a new thrust sprite every time. Who knows? But for now, let's say we have a final sprite sheet, right? And we might change this later, but just like not overcomplicate things for now. So the sprite sheet would be sprite sheet from, and this is where it gets interesting. So, and you know what we're going to do is we're going to say sprite sheet from image asset. So that actually makes a lot of sense. So we're going to say sprite sheet from image asset, and then we're going to give this image asset, and then we say basically the image. Actually, let me make this a static like this. So we're gonna say return a new sprite sheet, and we have the asset.image path. We have the sprite width. Sprite width is the asset.width. No, that's not true. So basically, you have to calculate this. The final sprite width is the asset.width divided by the asset.calls, and then the sprite height is the height divided by the rows, and so we have the sprite width, and then we have the sprite height. And then what else do we need? And then we have the rows and calls. So we have the asset, the rows is the asset, the rows, and then the calls is the asset dot calls. Okay. So the sprite width is an int. Okay, so this needs to be an integer division. And okay, so now we have the spreadsheet. So now we can actually go here, from image asset, we just pass our asset. Okay, so now we got a sprite sheet. And okay, so we got that. So the question is like, what kind of job do we give the sprite sheet, right? Should the sprite sheet render? Probably not. The sprite sheet is just there to manage like all these sprites. allow us to access them, and so on. So at this point, what I'm actually going to do is I'm going to look at if we are fine with our analysis. We're going to just fix up our code. But basically, okay, so this is a kind of, doesn't make much sense here. Yeah, so basically what we want to do, we don't actually need this anymore. Basically, the thirst sprite is self-explanatory. We don't need to. It has all these information. And so, what is it complaining about? Oh, it needs to be a thirst sprite. Okay. All right. So the thirst sprite, we actually don't need the thirst image path anymore at all. Don't need that. Okay, SpriteSheet isn't used yet. Fine. So I'll stop here. I'm going to be back in about 5 minutes for the last one for today. We're going to do it just like 45 minutes before I will have some dinner. But what I wanted to make sure is that this still works. Okay, so we need to select. I should say that this still works, it still compiles, and it still runs. And then we'll check this in, tag it, and go from there. Okay, so we have a problem here. New SpriteSheet. The method error was called on null. Okay, so we need to obviously first make this a list. Right, and so actually what we could do is we could do row times calls, rows times calls, and then, so we pre-allocate, since we have to do this anyways, so we say row, and then the times number of calls plus the call, and then that's the sprite. Right, think about this. So basically we take the row, which row we are in. So if it's 0, it will just be the call. It will start there. But if we have row 1, we basically end up going to the end of the list. We already talked about this. If this is still confusing, look at the first episode. Watch the first episode, and it basically explains how this works, like making a 2-dimensional list and representing it as a 1-dimensional list. Okay, so now it still works. We have this warning, that's fine. We will use it in a second. So let me check all this stuff in. And we'll say SpriteSheet implemented and thrust sheet prepared. Okay, so then we tag this with, so let's see how it tags were. So we got, this was episode, this is 7, this is the end, and we'll push and post the tags, and then I'll sign off, and I'll be back in about, well, now it's already 7, it's 5 o'clock here, 7 o'clock Eastern, but we'll be back at the top of the hour. And if I could see my screen over here, and now I can, I will stop streaming for a second, and we'll be back in 5 minutes.